Hello everyone, welcome to the session. So in this particular session, I'll talk about problem number 3, which is based on recursive tree approach. Okay, we'll try to solve this problem as well so that we will be able to get a very clear understanding and the insights about recursive tree approach. So let's get started. For example, a recurrence relation is given to me. A given recurrence relation is, so a recurrence relation is given to us, which indicates that the value of t of n is something which is equals to 1 when I am having the value of n is equals to 1, and when the value of n is greater than 1, at that point of time it is something which is equals to t of n by 2 plus t of n by 3 plus, let me write it further here, t of n by 5 plus c, when the value of n is greater than 1. This is a kind of a recurrence relation that we have. Now, the important point here to understand is that here we are having 3 different recursive terms. Until so far, the problem number 1 and the problem number 2, which I have discussed based on recursive tree approach, we have seen that only 2 recursive terms were there. But here we are having 3 different recursive terms. But it's not an issue. Why? Because here again, if you will see, instead of making that binary kind of a tree, we are making ternary kind of tree. That's the only difference that we have here. So we are having this n number of elements. We are dividing the number of trees. So here the element is split into 3 halves, where first half is n by 2, second half will contain elements as n by 3, third half will contain n by 5. Now the cost required to do this particular split is, we can say as C, right? We are doing a splitting into 3 halves, n by 2, n by 3 and n by 5. Now here if you will see, just observe one thing. On the left side we are multiplying our data or the elements by 1 by 2. In middle we are multiplying with 1 by 3. In the right we are multiplying with 1 by 5. So the same thing we are trying to do here with the same approach. So here the cost requirement will be, because here in the first case when I am dividing my n into 3 halves, the cost requirement is C. So it means that when we are dividing our n by 2 into 3 halves, n by 3 into 3 halves and n by 5 into 3 halves, each is having a cost requirement as C only. So in total the cost will be 3C, right? So here it will be n by 2 to the power 2, here it will be n by 2 into 3, here it will be n by 2 into 5. Similarly, here it will be n by 3 to the power 3 into 2, because on the right side, on the left side, multiplication by 1 by 2, in the middle, multiplication by 1 by 3, in the right, multiplication by n by 5. Similarly, here as well, n by 2 we can say, n by 5 into 3 we can say, and n by 5 square, and so on. Now here if you will see, if you will try to observe the pattern, at each and every time, here the cost again, there will be a 3 times splitting will be done, here as well, right? Here as well, here as well, here as well, here as well, and here as well. Now here it will be nothing but is equals to 3 to the power 2c, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9c. The question is that now instead of having only the left hand and the right, in this recursive tree that I have created here, so in this particular recursive tree that we have created just now, the question is how many different kinds of splits that we have. So when we are having a left side, in that particular case what we are trying to do is that we are saying n by 2 to the power k, which is equals to 1. So here the value of n is equals to 2 to the power k. So here the value of k is equals to log of n base 2, right? This is what we are getting. If suppose we are talking about the middle one, if suppose we are talking about the middle side, at that point of time we are saying that we are having n by what we can say 3 by k, 3 to the power k, because at each and every time in the middle portion we are dividing the values by 3 by 3 by 3 and so on, which is equals to 1. So here the value of n or the value of k is something which we are getting as log of n base 3, right? And on the right side, if you will observe here, what we are getting the value as, we are trying to do the split on the basis of n by, I would say 5 to the power k, which is equals to 1. So here again the value of k is equals to log of n base 5. So here we are getting 3 different values of k. One is something called as log of n base 2. One is something called as log of n base 3. One is something which we called as log of n base 5, right? Now the question is that which particular value of k is higher value, which is having a lower base. So can I say that this is something which is having a higher value? Yes, out of these 3. And at each and every time we are doing this, so at every level, so we got the level, maximum level is log of n base 2. And each and every level we are getting the power addition by 1. So in total what we can do is that we are saying that it will go, we can take c as common, 3 to the power 0 plus we can say 3 to the power 1 plus 3 to the power 2 plus 3 to the power 3, until how many number of levels it will go? It will go until value of log of n base 2. Log of n base 2. So here the value of a is equals to 1. Here the common ratio is 3, right? So it's a GP series where the common ratio is greater than 1. So in that case, the sum of the GP series will be a into r to the power n minus 1 divided by r minus 1. Here the value of a which we are getting is 1 only. The value of r is 3. The value of n is log of n base 2 minus 1 divided by 3 minus 1. I have just imputed the value. And outside that, we are having the value as c. Outside that, we are having the value as c. If you will try to solve this, you can take the value of n here at the upfront and 3 at the log of 3 base 2 minus 1 divided by 2 into c. In terms of big O, I can say that you will get value approximately n to the power 1.5. So this is something where you can say that this is a big O time complexity, which is, you can also write it as big O of n square, right? So this is the overall way to solve any recurrence relation using, again, recursive tree approach. Here, how this problem is somewhere different from the previous problems and why I introduced this problem. The major objective here is to make you guys understand that yes, here if you will observe, we are having 3 different kinds of recursive recurrence relations, right? Recursive terms are there. That is 3. Now, I hope that if you are getting 4, 5, n number of times also, it's just that you have to create a tree accordingly, and then you will be able to clearly calculate that what is the value of k. Here, if suppose you are doing a binary split, you will be able to get 2 k's, whichever is having a higher value of k, that you can pick up. Apart from that, if suppose you are doing 3 times split, accordingly you will have 3 values of k and so on. It means that the value of k, how many number of values of different k's you can get, it depends on how many number of splits you are doing for a tree, for a recursive tree. And accordingly you can calculate. And finally, you will be able to get the overall big O time complexity by solving just a GP series. Here you can also have a AP series as well. It's just that you should know that what is the formula to compute the sum of AP series or the GP series that you are getting here. I hope that I am making sense to everyone. If you still have any sort of doubt, do let me know. I'll for sure try to resolve it as soon as possible. With this, happy learning to all. See you soon in the next upcoming session.